In this lecture, we try to flatten the data in the JSON columns and extract the selected data from the lists or dictionaries. For instance, we could extract the name of the collection that the movie belongs to. So we have here the belongs to collection column. And let's have a look at the very first element. And here in the first movie, the collection is the Toy Story collection. And actually, it would be good if we could simply extract the Toy Story collection from the dictionary here. So in this dictionary, in total, we have 4 key value pairs. And we are only interested in the second one. So the name of the collection is the Toy Story collection. And therefore, we can do the following. So we can apply the following function on each and every element in the belongs to collection column. And first of all, we should check whether the element is a dictionary or not. So if we do not have a dictionary, then probably we do not have any information on the collection. And probably there doesn't exist a collection. So if it's not an instance of dictionary, then we should have a missing value. And if we have a dictionary, then we should actually get the name here. So Toy Story collection. So this is nothing else than getting the value for the key name. And let's overwrite the column belongs to collection. And let's have a look here. And here we have Toy Story collection. Then we have the second movie that does not belong to a collection. Then we have Grumpy Old Man and so on. And we can also use the value counts method to actually check whether we get reasonable results. And in total, we have 40,000 movies that do not belong to a collection. And actually, the largest collection is the Bovary Boys. Now let's go on and let's have a look at the genre column. So here we have lists with dictionaries. And let's have a look at the very first element. And the very first movie has actually 3 genres: animation, comedy, and family. So that's Toy Story. And the plan is now to extract the 3 genres and put them into one string separated by a pipe symbol, for example. So I prefer a pipe symbol because a comma is more common. And this could cause problems. So a pipe symbol is pretty unique and only rarely used. So with for I next, we iterate over the dictionary and get all genre names and join them with a pipe symbol. And then we overwrite the genre column. And let's have a look here at the first element. Now we have a string with the 3 genres separated by a pipe: animation, comedy, and family. And again, let's use the value counts method to make a cross-check. And obviously, the fourth most frequent value is an empty string with 2,442 instances. And this doesn't really make sense. And before, this was an empty list in the genre column. So we simply do not know the genre, and therefore, instead of having here an empty string, we should replace this with a missing value. And we can do this with the replace method. So we replace empty strings with np.nan. And let's again check here with value counts. And now we have here 2,442 missing values. All right, now let's go on. And let's have a look at the spoken languages column. So movies can have more than just one spoken language. And for instance, here we can see an empty list. So probably for this movie, we simply do not know the spoken languages. And this should result in a missing value rather than an empty string. So that's the same as before in the genre column. And actually, we apply the very same lambda function on spoken languages. And also here we are only interested in the key value pair with the key name. And we are actually interested in the value, for instance, English. So we iterate over the list and take all languages and join all languages with a pipe. And again, we check before whether the element is here a list or not, and if not, then we create a missing value. And also here we override spoken languages. And again, let's make a cross-check. And also here we can see that the second most frequent value is actually an empty string. And again, we use the replace method to replace it with a missing value. And the same we can also do for production countries and production companies. So first of all, for production countries. And obviously also here we could identify missing values. So 6,282. And let's create those missing values here with replace. And the same we can do for production companies. And also here we have empty lists, and these are actually missing values. And in total we have 11,800 missing values. So for almost 12,000 movies, we do not know the production companies. And finally, let's check the number of missing values in all columns. And let's compare this to the original or the initial data frame that was uncleaned. So we didn't create any new missing values in the belongs to collection column. But before we had in the columns production companies and production countries only 3 missing values. But actually we identified many more missing values. So now we have almost 12,000 here and over 6,000 in the production countries column. And actually this is also part of data cleaning, identifying and creating new missing values where appropriate. And having many missing values doesn't necessarily mean that we have unclean data. So it can also mean that the data doesn't exist. So Titanic is simply not part of a collection. And then in the next step, for some missing values, we can consider to remove them or to find appropriate replacement values. So again, missing data doesn't necessarily mean unclean data, and identifying hidden missing values is also part of data cleaning. Alright, thanks for watching, and see you also in the next lecture. Bye.